Alright, so this is take 2 of the chi-square assignment. I'm not in the resolution just yet, so we're still in my normal resolution, so don't worry about it right now. But I'm starting off in the assignment section anyway. We're going to zoom in, kind of try to correct this resolution. So you'll see the chi-square lab right here. What we're going to do is we're going to right-click, open link in a new tab, or new window. Both work. And now we have a zoomed in version of this. So I'm going to File, Make Copy, and that will produce a copy of this. Very good. Alright, it is already filtered for you. If you want to filter, how you do that is you highlight the top row like so, and you hit this little oil filter up here. As it. If you ever hit to a point where you have like a smaller screen, it's going to be behind a triple dot. You see the filter right there. Add this triple dot. So now what we're doing is you need to make a chi-square. We have a sample size of 50. And we need to formulate a hypothesis. Okay? So our hypothesis are 2 variables that I'm picking out. It's going to be orientation and family stress levels. Null is orientation does not impact stress levels, family stress levels. Our hypothesis is orientation has an impact on stress levels. Having some issues typing, I guess. So, alright, now that we have that, let's go ahead and highlight A through D. We're going to insert pivot table. We're going to put this on a new sheet. Okay. And now we hit this big area. Because what we're going to do here, our unit of analysis is person. Okay. So we're going to take the person here and we're going to add it to values. Click and drag it on over. And we're going to summarize by count. So now we have our sample size over here, which is 50. And now let's go back to our first sheet. Family stress levels and orientation. We're saying that orientation has an impact on those stress levels. In other words, your stress, in this case for the hypothesis, stress depends on sexual orientation. So we put our dependent variable in rows. Back to the hypothesis, we're saying that family stress levels depend on this orientation. So we're going to take stress, put it in our rows. Okay? Now our orientation is going to go into the high row. The columns, rather. Go ahead and drag this down the columns. There we go. So now we have our table. So go ahead and highlight this table. Right-click, copy. We're going to go to another sheet. And we're going to paste special values only. Now we're going to clean this table up. Remove all these blanks with right-click on wherever these blanks are on your sheet. Delete row. See this B? We're going to delete this column. Right-click, delete column. Now we're left with a cleaner table. So we're going to highlight. We can get rid of this too. Alright, so we're going to highlight this, copy it, and just going to do a normal paste. So we have our actual table right here. And our null hypothesis table right here, or our, what this is called is your expected table. Right, so for our expected table, we're going to delete all the things in there except for your total values. And we're going to leave this one alone. So we're going to do calculations equal grand total multiplied by column total divided by grand total. We'll get a number. All right, we're going to do this quickly. We're going to do this quickly by implementing the dollar signs, by holding constant, dollar sign in front of the E, dollar sign in front of the 11. The reason that works is E is the column. And we're saying, hey, don't let E move. And then 11 is the row. So we're saying, hey, don't let 11 move. In this case, don't let E11 move at all. And we're going to do the same thing for, it's a 3x3 grid, so it doesn't matter which way we do it. We're going to do the same thing for our purple value here, B and 11. Enter. Now we can click and drag like so. You can see it adjusts it, but it held these two constant again. We don't have dollar signs on E8, so this one's going to move down when we drag it down, but we have the rest of them frozen. So the purple box and the blue box won't, and as you can see, yellow box moved, purple and blue did not. Yellow box moved, purple and blue did not. Alright, so we're going to do the same thing, equal, row, times, column, divided by grand. We're going to hold purple, and teal, or blue, constant. Just going to go ahead and equal, row, times column, divided by grand. Same thing. Same exact thing we've been doing. We're just going to highlight both of these and drag them down now. And that's our, this is our null hypothesis. This is the expected numbers if everything were to be evenly distributed. Okay? In other words, if everything was equal odds, if you were equally as odds to be as stressed if you were homosexual as if you were heterosexual or bisexual in this case. And this is your actual table. Now you can just look back and forth here if something over indexes. For example, take a look at this column right here, the homosexual column. 8 is the actual, but if everything were to be held even, it should be 4, is what this test is saying. Okay? In other words, in reality, if you're homosexual, then you're pretty much expecting double the amount of stress, okay? Or at least you're double more likely to have that stress. For high stress, you can see it's high stress. Now for low stress, you can see if all things held equal, then there's supposed to be more people in the low stress count, but in actuality, there's less people. You see how this works? Now medium, it looks like it actually held out. Medium is as expected because these numbers match up quite nicely. So we can just eyeball it all day, but let's go ahead and do a mathematical test, okay? We're going to do equal chi-test. We're going to highlight the actual numbers here, okay? Not the totals. Don't ever use the totals. Comma. We're going to highlight the hypothesized, or the null hypothesis table, like that. And again, not the total. Close it, enter. This is our p-value. P-value of 0.07, or 0.08 if you round it, which means it is above the number of 0.05, which means we have to accept null, but just barely. There's not enough differences in these tables for us to reject null, but if we had more sample size, this would probably reject. It's so close. It's 3% off. So you could definitely make a case that you know, this is you just need more sample. And this is how you do chi-square. I will see everyone in class or online if you're online.